Shall we begin? Welcome to Flash Revision Lab. I'm your tutor, and we'll master this topic in a flash. Today, we'll be looking into the world of electron shells and the history of the periodic table. First, let's dive into the electron structure of atoms. Electrons in an atom are arranged in energy levels or shells. Each shell has a maximum number of electrons it can hold. The first shell can hold up to 2 electrons, the second shell can hold 8, and the third shell can also hold 8. The electrons in the atoms fill up in order, starting from the innermost shell first, and move on to the next when the shell is full. When it comes to drawing electron structure diagrams, you can represent electrons as dots or crosses around the nucleus. Start by drawing concentric circles representing the shells and place electrons in the shells, following the order we just discussed. For example, if we have a sodium atom, which has 11 electrons, there would be 2 electrons in the first shell, 8 electrons in the second, and 1 electron in the third. To write electron configurations, you can use a simple notation showing the number of electrons in each shell. So for sodium, the configuration would just be 281. Now, onto the periodic table. Before scientists discovered subatomic particles, they used to arrange elements based on their atomic weight, not their atomic number. As they sorted elements by mass, they noticed patterns emerging at regular intervals, which is why it's called the periodic table. The early periodic tables weren't perfect. Some elements were misplaced to fill gaps, and others were sorted only by atomic weight, ignoring their chemical properties. In 1869, Russian chemist Dmitry Mendeleev created his first draft of the periodic table. He organized elements into columns based on their properties and arranged them horizontally by increasing atomic weight. This made chemically similar elements fall into the same columns. However, there were some exceptions, as a few elements didn't fit the pattern when sorted by atomic weight. Mendeleev didn't force them into the table. Instead, he left gaps for undiscovered elements. He also switched the order of some elements to keep consistency in the columns. Mendeleev realized that elements with similar properties should be in the same column, and he predicted the properties of undiscovered elements based on the trends in their group. When those elements were eventually discovered, it confirmed Mendeleev's theories. But there were still some elements that didn't fit neatly into his table, partly because isotopes were unknown back then. After the discovery of subatomic particles, scientists calculated the atomic number for each element, which they now use to arrange the modern-day periodic table. This arrangement aligns with Mendeleev's patterns and provides a more accurate understanding of the elements. The modern periodic table arranges elements in order of increasing atomic number. As you go from left to right across the table, each element has one more proton than the element before it. This arrangement ensures that elements with similar properties end up in the same columns. The periodic table is organized into vertical columns called groups and horizontal rows called periods. Periods indicate the number of electron shells an atom has. They're numbered from 1 to 7. For example, elements in period 2 have 2 electron shells, while elements in period 3 have 3. Groups represent the number of outer electrons in an atom. They're numbered from 1 to 8, with a final group also called group 0. So, group 4 elements have atoms with 4 electrons in their outermost shell, while group 6 elements have atoms with 6. As we look at the periodic table, it's important to recognize the differences between metals and non-metals. Metals are usually found on the left side of the table, and they tend to have some common properties. They are generally shiny, good conductors of heat and electricity, malleable, and ductile. This means they can be bent or hammered into various shapes without breaking, and can also be drawn into wires. On the other hand, non-metals are located on the right side of the table. Their properties are quite different from metals. Non-metals are usually not shiny, and they are poor conductors of heat and electricity. They are also more brittle, which means they can break or shatter easily when subjected to force. In summary, metals and non-metals have contrasting properties, which helps us better understand how they behave and interact in chemical reactions. And that's a wrap on these topics. Thanks for joining me at Flash Revision Lab. If you found this video helpful, don't forget to like, subscribe, and hit that notification bell for more rapid revision content. If you have questions or need some extra help, drop a comment below or reach out to us on our social media channels. Remember, with Flash Revision Lab, you're just a flash away from acing your exams. Until next time, happy revising!